Learning target 4 says I can factor non-monic polynomials and solve polynomial equations. So this is going to be a mix of just factoring problems and equation solving problems. But there will be factoring involved in each one. So let's start out with just a factoring problem. Now notice that this is non-monic because the leading coefficient here is a 3. Also notice that this is a polynomial, it's not just a quadratic, because see how the highest exponent is actually a 4. So this is a little bit more complicated than what we did in the last video, which was just factoring monic quadratics. So let's jump into factoring this non-monic polynomial. Now, whenever I do any kind of factoring problem, ever, I always look first to see if there's a greatest common factor or a GCF that I can factor out. So looking at these three terms, I'm going to look and see, is there a number that's a factor of all three of the coefficients? And is there a variable that's a factor of all three of the variable parts of the terms? So first, let's think about the number parts. So here we have a 3, and a negative 36. So the number 3 would be a factor of all three of those. So we can definitely pull a 3 out from all three of these terms. But if you notice, all three of the terms have an x part. And in particular, this term has 4 x's multiplied together, this term has 3 x's multiplied together, and this term has 2 x's multiplied together. So since all of them have at least 2 x's multiplied together, we can factor out an x squared from all three of the terms. Now remember, GCF factoring is sort of like undoing distribution. So it's like sort of like a distribution problem in reverse. So what we want to do is we want to think about what numbers would have to be left over inside these parentheses so that if we multiplied the 3x squared, we would actually get out this problem here. So let's think about it term by term. So first let's think about 3x squared times what would equal 3x to the 4th. Well, we already have our 3 in there, so we really just need to go from x squared to x to the 4th. And to do that, we're just going to have to multiply by 2 more x's. So, x squared. Looking at our next term, we have 3x to the 3rd. So again, we want to think to ourselves, 3x squared times what would equal 3x to the 3rd? Well, we already have the 3, and we're sort of starting at x squared, so we just have to multiply by 1 more x. And finally, let's look at our last term. We want to think about 3x squared times what would equal negative 36x squared. So we already have the x squared taken care of. We're not going to have to multiply by any more x's. But here we have a 3, and here we have a negative 36. So we have to think about, well, how do we get from our 3 to our negative 36? Well, we would have to multiply by a negative 12. So that's the last piece left inside the parentheses. And as I said, GCF factoring is sort of like undoing distribution. So if you want to check your work, you can always try to like redistribute this 3x squared and make sure that you actually get out what you think you should. So what we've done so far is we've just factored out a GCF from a non-monic polynomial. However, if you notice, what's left over inside these parentheses actually looks a lot like a kind of problem that I might have given you for learning target 3 that you could factor further. So what we're going to do now is think about how can we factor that x squared plus x minus 12 part further. So I'm going to turn to my multiplication box. Remember that any kind of a monic quadratic will always will always factor into x plus some number times x plus some other number. So our x squared will go in our top left box, our negative 12 will go in the bottom right. Now these other two terms are going to be something times x, and we have to think about what numbers we should put in front of those x's. Now, what we need for a monic quadratic, remember, is that we need two numbers that multiply to make this negative 12 and add to make this positive 1. Remember, there is a little coefficient of 1 in front of the x. We generally don't write it like that, but there is a coefficient of 1 in front of the x. So we need two numbers that multiply to make negative 12. So in the second problem, we want to factor 5x squared minus 7x minus 6. Now, again, the first thing I always do whenever I have a factoring problem is I check to see if there's a GCF that I can factor out of all three terms. So looking at the number pieces, there's not some nice common factor that I can factor out from 5, a negative 7, and a negative 6. Also, not all of these terms have x's in them, so I can't factor out a variable piece. So I'm just going to jump right into my multiplication box. Now, if you notice, this is not a monic quadratic. The leading coefficient is not 1. So we're still going to be able to use a multiplication box to factor, but the technique is just going to be a little bit more complicated than what we had with monic quadratics. So I'm going to start setting up my multiplication box. Now here's how it's going to be different already from the start. With a monic quadratic, we said that that was going to factor into x plus some number times x some other number. Here's the problem. In this case, since we have a 5 in front of our x squared, since this is a non-monic quadratic, we can't just get this 5x squared term by multiplying x by x. One or both of these x's is going to have a number in front of it. So we're going to end up needing to figure out all 4 of these numbers, and that's what makes this problem a little bit more difficult. Now, our x squared term is still going to go in the top left-hand box because it's going to come from having been having multiplied this some number times x by this some number times x. So our 5x squared is still going to go in our top left-hand box. And our negative 6 is still going to be in the bottom right box because it will come from having multiplied this number and this number. So our negative 6 will go here. Now, these other two boxes are going to have some number times x, and we need to figure out what number goes in front of these x's. Here's where we start getting different from what we had in our monic quadratic situation. So with a monic quadratic, what we'd be looking for at this point would be two numbers that multiply to make a negative 6 and add to make a negative 7. It's going to be a little bit more complicated now that we're working with a non-monic quadratic. The first thing that we are going to do is we're going to take our leading coefficient 5 with our constant term negative 6, and we're going to multiply those together. So we're going to multiply 5 times negative 6, and that's equal to negative 30. Now, with a non-monic quadratic, instead of looking for two numbers that multiply to make this negative 6, we're going to look for two numbers that multiply to make this negative 30. So we need two numbers that multiply to make negative 30. We are still going to look for two numbers that add to make the negative 7, though. So two numbers that would work would be negative 10, would be a negative 10 and a positive 3. So those will definitely add up to make a -7, and they'll multiply to make a -30. So those are going to be the numbers that are going to go inside my boxes. So I'll pick one to be -10, and I'll pick one to be a +3. Now we have to figure out how to fill in the outside so that it actually multiplies to make the inside. And this is a little bit uglier than it is for monic quadratics. So here's a strategy that is going to work for non-monics. So here's what I'm going to do. I'm going to look at each row. I know this box came from multiplying this term times this term, and this box came from multiplying this term times this term. So whatever goes here better be a common factor of each of these two boxes. So let's think to ourselves, what would be a common factor of each of those two boxes? Well, this first box has a 5 and an x squared. Second box has a -10 and an x. So just in terms of the numbers, we have a 5 and a -10. 5 would be a factor of each of those. And if you notice, there's an x squared here and just an x here, so we can definitely pull out that x as being a factor of both of them. Now let's do the same thing with the bottom row. This box came from multiplying this term times this term. This box came from multiplying this term times this term. So whatever goes here has to be a factor of each of these two pieces. And if we look at that, they don't both have an x, so we're not going to be able to pull out an x as we expected. But both of those two boxes has a factor of 3 in them, so we're going to be able to say that 3 is a factor of both of those boxes. So now that we have the left-hand side filled in, we can figure out what needs to go at the top of the box to make everything multiply correctly. So let's look up here. So this box is a 5x squared, and that came from having multiplied 5x by whatever is here. So to get from 5x to 5x squared, we only have to multiply by just x, just a single x. And then we can check, does 3 and x multiply to make 3x? It does. So now let's look over here. Here I have a -10x that came from multiplying the 5x by whatever number is up here. So to get from 5x to 10x, we must have multiplied by a -2. And we can check, does 3 times -2 actually make a -6? It does. So our final answer is just going to be these two factors. So moving on to problem number 3. Problem number 3 asks us to solve for x. So just as a reminder, whenever we see something that says to solve for x, that means we are not just going to stop at factoring, we actually want to find the values of x that make this true. So the first thing that we're always going to do to solve an equation is we're going to start out by getting all the terms over to one side, set equal to 0. So if you notice, I have this little -3 off on the side by itself. We want to move it over to the other side by adding 3 to both sides. So then we just have a polynomial set equal to 0. The next thing that we want to do is we want to factor this polynomial. Now, looking at this, there's not a GCF that I can see that I can pull out of all 3 terms. There aren't any nice factors of 4, -8, and 3. Also, although there's an x in both the first term and the second term, there isn't one in the third term. So we also can't pull out a greatest common factor of x. So we're just going to have to use our multiplication box to factor this non-monic quadratic. So let's get our multiplication box set up. As we saw earlier, our x squared term is going to end up in the top left corner, and our constant term, the plus 3, will end up in the bottom right corner. We know that these two other parts of the multiplication box will have some number times x, and we know that we need to figure out what numbers are going to go in front of those x's. Now, since this is a non-monic quadratic, what we have to do first is we have to say, okay, what's 4 times 3? What's the leading coefficient times the constant term, which is 12? And then we're going to look for two numbers that multiply to make a positive 12 and add to make a negative 8. So two numbers that would work would be negative 6 and negative 2. Those would add up to make negative 8, but multiply to make a positive 12. So I'm going to put one of those in the top right box and one of them in the bottom left box. So I'm just going to put negative 6 here and negative 2 here. So now I have the inside of my multiplication box all filled in, and I need to figure out what's going to go on the outside. So what I'm going to do is I'm going to look at each row and think about what would be a common factor of each of these two terms. And again, that's because this box comes from multiplying here by here, and this box comes from multiplying the number here by the number here, or expression, or whatever. So whatever's here needs to be a factor of both the 4x squared and the negative 2x. So looking at these two boxes, we see that we have a 4 and a negative 2. So 2 would be a factor of both of those, and in one of them we have an x squared, and in one of them we have an x, so 2x would be a factor of each of those two terms. Now, looking at the bottom row, we have a negative 6x and we have a positive 3. It's sometimes a little tricky to decide whether you should pull out, in this case, a negative 3 or a positive 3, so sometimes there's a little bit of sort of guess and check that we have to do. I'm going to pull out a negative just because there's a negative in front of the x, which makes me think that maybe I should pull out the negative 3 instead. So then what I can do is I can figure out what needs to go on the top so that everything will all multiply out correctly. So let's look at the 4x squared box. That comes from multiplying 2x by whatever is up here. So to get from 2x to 4x squared, I'm going to have to multiply by 2x. And now that I've done this, let me just double check. Does 2x times negative 3 equal negative 6x? And it does. So that's what I want to happen. So now let's go up here. So here we have a negative 2x. That comes from multiplying this 2x by whatever number is up here. We better put a negative 1 up there in order to make it multiply, in order to make the 2x and the negative 1 multiply to make a negative 2x. And let's just double check. Does 3 times negative 1 equal 3? It does. So we have filled in the outside of our multiplication box appropriately. So our factors are going to be 2x minus 3 times 2x minus 1. Now don't forget, this was a solving problem. This was solving an equation. So our goal is to find the values of x that make this true. And we did the factoring just to factor this left-hand side of the equation. But there's still this little equals 0 that we have to keep in mind. So now we have something factored equal to 0, so we can use the zero product property. So that says that either the 2x, I'm going to do this in different colors, so either the 2x minus 3 is equal to 0, or the 2x minus 1 is equal to 0, and we just need to solve for x in each of these two possibilities. So here we would get that 2x equals 3, so x equals 3 over 2. And in this case, we would get that 2x equals 1, so x equals 1 over 2. So our two possible solutions would be x equals 1/2 and x equals 3 over 2. Now let's just quickly review what we've done here. So first we took our equation and we got it so that we had everything all on one side set equal to 0. Then to factor we used our multiplication box. Once we had our two factors, we sort of put it back into the equation and we used the zero product property to solve. Problem 4 says to solve for x, so this is another equation to solve. I can tell that I actually want to solve the equation and not just factor it because the directions ask me to solve for x. So the first thing that we'll do to solve an equation is to get all the terms over to one side. So to do that, we're going to add 12x squared to both sides. And we're going to add 18x to both sides. And then we're just left with 0 on the right-hand side. Next, what we're going to try to do is we're going to try to factor the left-hand side, because we know if we can get the left-hand side completely factored, we'll be able to use the zero product property to solve. Now, as I've said before, the first thing I look for in a factoring problem to make my life a little bit easier is to see if there's a greatest common factor, or a GCF, that I can pull out of all three terms. So looking at this, I'm going to look at my numbers first and then I'll look at my variables. So looking at the number 2, 12, and 18, I can see that 2 is a factor of all of those. Those are all even numbers. So I'll be able to pull out a greatest common factor of 2. But looking at the variable pieces, I have an x cubed and an x squared and an x in these three terms. So notice that each of those has at least one x, at least one factor of x. So we can also pull out an x as part of that GCF. But remember, now we need to think about, okay, so what should be left inside these parentheses so that what we have on this line and this line are actually equivalent. Or, in other words, so that what we have on this line would actually multiply out to make what we had in the first line. So we need to think to ourselves what we need to put inside the parentheses to make these two lines equivalent. So the first thing I'm going to do is I'm going to think to myself, 2x times what would be equal to 2x cubed. So you notice they both have the 2, and the GCF has an x, but in order to get from 2x to 2x squared, we're going to have to multiply by 2 more x's. So inside the parentheses, we're going to need to have an x squared as our first term. The next thing I'm going to do is think about 2x times what would give me 12x squared. Well, to get from the 2 to the 12, we're going to have to multiply by 6. And to get from the x to the x squared, I'll have to multiply by another x. Now finally, let's think about the last term inside the parentheses. So we want to think about 2x times what would give us an 18x. So both of them have the x already, but we need to get from 2 to 18, so we're going to have to multiply by 9. So what we have left on the inside of the parentheses is x squared plus 6x plus 9. Now, whenever we pull out a GCF, we next need to think to ourselves, can we factor the inside piece any further? So looking at this, we see that we have a monic quadratic. So let's just start setting up our multiplication box to try to factor that out further. Now, we know that our x squared will go in our top left corner, and our plus 9 will go in our bottom right corner, and then each of these two other boxes will have something times x. So then the two numbers that are going to go in front of those x's for a monic quadratic will be two numbers that multiply to make a 9 and add to make a 6. So two numbers that would work there would be 3 and 3. Now at this step we just need to sort of fill in the rest of the multiplication box to make it, fill in the outside of the multiplication box to make it so that it would actually multiply to make the inside. So we know with a monic quadratic outside here we're going to have x's. Then we can think to ourselves, okay, what would need to go up here so that this x would multiply with this number to make 3x? So we need for up here to have a plus 3. Same thing down here. If we thought about x times what would give us 3x, we would need to multiply our x by a positive 3. And then we can just sort of check for ourselves, does the 3 and the 3 multiply to make the 9? It does. So our two factors will be x plus 3 and x plus 3. Now, what I'm going to do is I'm going to rewrite my equation with those two factors in place of this quadratic that we just factored. Now remember though, these two factors are only equal to this inside piece, so we still need to keep our 2x on the outside. We still have our equals to 0. Now that we have our equation completely factored, we can now use the zero product property to solve. So the zero product property says that if you have a product of multiple things that are equal to 0, at least one of them has to be 0. So either 2x is 0, or x plus 3 is 0, or this x plus 3 is 0. So to solve this equation, we'll divide both sides by 2, and we just get x equals 0. To solve this equation, we'll subtract 3 from both sides, and we get x is negative 3, and we also get x is negative 3 from this equation. So we only have two distinct solutions to this equation, and they are x equals 0 and x equals negative 3.